This is a demonstration of the ex priori technology-assisted review products and services. In this demonstration, we're going to be covering the first 4 items on this list: the organizational structure of your case, developing a tagging structure to reflect that organizational structure, and then we're going into the product and show you how to explore on data and use predictive coding. We save for later demonstrations the determination of relevance best practices, and also the practice tips and Q&A activities associated with the product and service. Even with technology-assisted review, the goals of the eDiscovery process remain the same. That is to identify, collect, and process data into sets of documents discretely relevant to issues in your case. You use technology-assisted review for improved identification and also to speed the process. We use our tools to develop result sets of documents, those that are grouped to support particular issues, and then we tag those result sets for access purposes. You develop tags according to a plan, and you publish the reasons for each tag so your team will be able to relate to them. Tagging is very flexible, and you can change or add to your tagging structure at any time. What you see in front of you now is the core user interface for the product. There's also a management interface, which we're showing you now, and this is where we set up tags. And it's very easy to set up tags. We're going to first of all pull up the tagging structure that we've ad hoc created for the data in our data set. And you can see we can mark things as privileged or not responsive, non-responsive, and the like. We can also label them with respect to particular issue like trades or money. We've created in the past a number of tags that are just ad hoc, ABC, XYZ. We'll create a new tag right now, and we're going to call this one MNOP, in keeping with our alphabet here, and we'll describe this as documents in support of motion to dismiss, and we can call it a tag or we can call it a folder, either depending on how we've organized ourselves. We're just going to call this one a tag though, and we'll set it up, and we'll go to the 4th page now, and you can see that we've set up a tag MNOP. To complete our presentation of the tagging system, I'm going to populate the product with some documents. I'm going to use the word FASTO, and we'll explain the use of that to you later. And we'll do the query, and you'll see we've done a keyword search, and we've populated the product now with 54 documents. If we wanted to tag one of those products, we'd come down here and we'll punch on result set, and we would set up a tag. And once we decide to tag something, we just punch on that, and the pop-up comes up and will give us the opportunity to use our tags and merely to tag a document. Let's suppose we wanted to tag this one with the ABC tag. We would do that and submit it, and the document is now tagged. And that's how simple the tagging operation is. Once you identify documents as related to particular issues, just go back to the list of issues that you've created tags for and tag documents or groups of documents, and they'll be preserved with the tag in metadata. At the core of our product is the concept of associating content. Actually, we take a look at the content in files or documents, and without regard to where they are, we associate it with the content of other files or documents that are in the data set. And we do this in an automated basis. We're going to demonstrate that very clearly here in the use of visual concept search. We are now looking again at the user interface for the product. And you'll recall that I inserted the word FASTO into a keyword search box and did the keyword search, and we returned 54 documents. Before talking further about this, we should tell you something about the data set. We actually have loaded about 25,000 documents from the Enron data, and this is a data set that's used kind of universally to demonstrate products. And the word FASTO has a relationship to that data. FASTO was the chief financial officer who was found guilty of all kinds of crimes related to the Enron operation. And so when I've taken the word FASTO and added it, done a search here, we've returned 54 documents that actually contain the word FASTO. Now we'll show you the difference between doing a keyword search and a concept search. We're going to take the word FASTO and we're going to move it up here to the concept search box, and we're going to run a concept search. And you'll see now that we have 194 documents rather than just 54 documents. And what we've done actually is taken the content that was in the 54 documents and we've associated it with all the other content that appears in the data set that we have. And we have more than 54 documents. We have 194 documents at this point. Well, what is the significance of this? Well, in reality, FASTO may have sent an email to someone that had particular content in it, and two other people that are in the data set might have sent emails with the same content. Their emails will show up in this 194 documents as well. So we're, again, focused on the content of documents and not necessarily on just the keywords that are there. Well, how do we look at these documents? Well, we can sit here and read them. We bring them up one at a time. As you can see, we punch on the document here and the text of the document appears below. But we have some far more dramatic ways of looking at the information. First of all, as most of these are emails, we can actually look at an email network. Okay? This shows all of the senders in red and all the receivers in white. And you can see that there are patterns that you can see in the communication network that was at Enron. So let's suppose that we want to focus in on Schultes here as opposed to the balance of the people that appear on this network screen. All we have to do is punch on the word Schultes and come over here and update the active query. And as you'll see, we've immediately reduced the number of documents that we're looking at, and we're looking only at those documents which originated with Schultes. In this case, they were emails to the balance of the people that appear in the circular representation. This is extremely helpful in drilling down into looking at particular potential witnesses or other participants in the process that you would like to identify. Now, this is not the only way that we can look at information. We can actually look at these emails over time, and I want to focus in here on what we call sonar. And if you'll take a look at each one of these rings, they represent a particular date. They start off here at November 14th and grow and grow and go into later. So later is here in at 1:15:02. And you can see that Schultes represented here and shows the emails that Schultes had sent on a particular date to these people, and then on a separate date to these other two people. So in likelihood, these were different correspondences. And again, here's a third one over here that reflects the same. Again, this allows you to take a look at a time representation rather than just merely a linear representation. And it's helpful particularly once you're starting to drill down into particular people and what their level of participation in particular facts and circumstances were. Now I want to repopulate the FASTO search again at this point in time, just because it will demonstrate more completely a couple of the other aspects of the visual representations that we can look at. And let's look at FASTO in a timeline sequence. Here, this is a representation of monthly volumes of emails and other documentation that FASTO could have originated or been a part of, or again, what content or similar content might be there. We can actually, though, take it down from a month to a daily representation, and you can see that we have concentrations of emails in particular periods of time. If you want to look at, for example, March 2001 through July 2001, all you have to do is move the cursor, and you'll see that we have March from represented as a start time and the end of June as a finish time. And we've limited the search at this point. So we're able to drill down into things with respect to time. Again, we can look at the records. You can see that we have all 194 records represented here. We've not updated the active query at this point, though. So if we want to update the active query to just these few months, all we have to do is punch the active query button, and you can see first just displays as a monthly basis, but now it does on a daily basis, and we go from March to the end of June with a limited number of emails. We also are able, again, to look at the records at any given point in time. You can see we've reduced this to 76 records, and we can drill into those specific records and start looking at them as well. While we're looking at these records, we can do a number of very specific things that will be helpful in evaluating things. First of all, we can take a look at what terms are interesting to the software in respect of a particular record. This in part is what forms the basis for the associations of content with other records. Secondly, we can take a look at attachments to particular records just by punching on this icon, which is in the form of a paper clip. And you can see that there was one attachment to this particular record. And if we want to look at that attachment, all we have to do is punch on the attachment, and we can look at that record as well. If we want to tag any one of these records, all we have to do is pull the tagging mechanism down that we described earlier, and we can tag particular documents at this point in time as well. To illustrate one more point, I'm going to again repopulate with the entire FASTO search. We have 194 records there, and I want to show you that in each case when a record is brought up, we have the ability to look at near duplicates as well. And you can see this is a list of the near duplicates that are there. You can examine all of those and again take a look at the actual document that is the near duplicate merely by punching on the button here. And also you have the ability to tag that near duplicate for further action as well. And finally, there is a color scheme available to you so that you can actually designate colors and tags merely by punching on these buttons right here. We will not spend much time on this aspect at this point, but know that you can color code things and do other types of things to delineate particular actions or categorization of documents. It's something you can develop with your team, and it's important for you to know that there's more than one way to tag documents or to highlight their importance as you're going through the process. In doing searches, we all run into situations where there have been alternative spellings that might be used in a particular word. With a flip of the switch here on this icon, you can actually type in a word that you would like to add to the query, and you can see that there are other alternative words that are suggested. I use the word fast. We could actually use the word fasto. I'm not sure that it'll return much because it is a proper name. So no, this is just returns fasto. But if we look at the word fast just for illustration purposes, we indicate that we have these similar words appearing in the data set already that could appear as misspellings, such as fast, cast, fat, and others that might be there. All you have to do is click on these words like fast and last, and you can add those to the query that you are doing and update that query. Also, we have another capacity, and that is we can type in search suggestions to help you narrow in on things that might be related in concept. And let's type the word fast in again. And you can see that in the data set, the following similar root words appear, like fast, faster, then we have fasto with 81 references, fastest, fastacian, and fast track, all available to us as additional search suggestions. If we want to add those to the query to make sure that we have a more complete query, all we have to do is check them and then punch the Add to Query button. Also, to assist you in doing searches, we gather certain information. For example, we gather all custodians' names and have those available to you so that you can add them to a discrete word search or to a concept search and look through theirs. Here we see Dana Schultes. To get Miss Schultes there, we would, in fact, just have to do this and do a search on her name if we'd like to. We also do the same thing with sender domains, as you can see, on emails, and we do the same thing with recipient domains. Demonstration on practice tips, we'll show you how to develop filters that you can maintain with respect to a particular project, and those filters can be maintained. They're much like saved searches, but there are a couple of manifestations when using them that we'll explain there. In addition, there's one other point. You'll see that the search term results have highlighted terms. And in the case of a concept search, it will indicate also the exact term, like FASTO, as you see right here. But in addition, it will have terms that appear in multiple documents of similar interest. And you can see that when you've done an exact phrase search and turn up a document, the only highlight is of the term that you did the exact search upon. Now, as I indicated when we started the demonstration, the first two aspects of the product, the concept search and clustering, are really exploratory in nature. And I'd like to switch over now to the clustering and show you a few items in respect of clustering. When we do clustering, the software actually goes out and does associations of content for similarity in the same way, but it does it totally on its own initiative. You don't have to look at anything. And these clusters appear both in visual representation, as you can see, and also here at the side in a listing. You can see that the highlighted item on the left here is actually repeated in the balloon that shows up here. Also like to indicate that these are the way these groups of documents relate. So you can see there's a strong relationship between this clustering and this clustering, for example. Again, this is the machine doing this from a very objective and non-subjective point of view. As you can see, these clusters have various relationships. There's strong relationships based on the width of the line. And the way we deal with these clusters is to take a look at the records. So we have this first cluster right here, which is rated quantity, rank, quantity, rank. Those are apparently terms that were important at that point. And let's take a look at the records that back that up. And you can see we have 36 records in this cluster. Again, we can take a look at it, the first few, maybe the first 10% of these, and determine whether there are any documents of interest. We do the same thing with the second cluster. And you can see we have 3,078 documents included in this cluster. As always, we have the ability to look at interesting phrases, the near dupes, and also the attachments. The interesting phrases are again a part of what the associations are about. So you can take a look at those and see if there's anything of interest. One of the things about the interesting phrases, incidentally, is you can focus in on one of those if you'd like and just do a straight up search on that, and you'll find that there are 195 documents that relate to that particular search. Let's go back to the clustering again and pull it up. We are now looking at the clusters that relate to that search term, again, here's the quantity rank right here, and you can see that these have been limited now to the 105 representations on those terms. Going back to the graphical representation again, we can pick any one of these clusters that might appear important to us and do a search on those records, but we can also take a look at the timelines that are represented by particular clusters. And you can see right here we have a timeline that begins sometime in the year 2000 and carries out to sometime in 2002. That's a monthly representation. Again, we can do the daily representation. We can take a look at a very small time period if we'd like, just the same way we did in looking at the documents that we developed with Concept Search, and we can review those as well. Again, we can focus in on particular date ranges, have the documents that are affected appear in front of you. We can go back to the records that were there and look at those records. Here we would have to update the active query first. This will reduce the number of records that we're looking at. Let it load here for a moment. You can see that the density is less. And if we go back to the records, we now have 1,517 records as opposed to the 3,078. As I indicated, we can always look for interesting phrases. We can always look for attachments. And we can always look for near dupes with respect to any documents that are displayed in the records panel. Now, we have moved on to a different set of cluster, or a different cluster set in the same group to illustrate one more point. As with the concept search, we highlight the core concept in the cluster. In this case, it happens to be purchasers, but there are also words that are important that appear in this document and in all the documents that are clustered both by as a part of the taxonomy but also by concept. So you can see here the words right, title, guarantee. They're all in smaller reference, and so here's the word right, for example, and these words will appear in all of the documents that are a part of the same cluster. This again is another aid to you in analysis of the cluster itself. Finally, I'd like to make a couple of comments about clusters. There will be many clusters in each document set that you are reviewing, and it may seem tedious at first to take a look at these clusters. Those people that have used clusters successfully have done it in the following way. Number one, they assign a couple of people to it in order to have them review all clusters and decide which clusters are relevant and not. Those that use it on a regular basis have pointed out to me that in fact it's very helpful because they learn how to look at the document set in a different way or multiple ways. And those who have been very successful with it indicate to me that in fact they have always learned a new way of looking at the information that was not suggested by human or manual review. One other word about the review of documents, and on the screen here you'll see this word hyperdupes. Hyperdupes are just a way we label exact duplicates, and so this document will be represented here. You can see it's Mahonia transaction documents, and if you open the drop down, you'll see that the same last reference appears in each case. And you can look at each one of these documents. When you do a production, though, and you're looking at exact dupes, those will be eliminated from those required for manual review unless you indicate otherwise. Now we turn to the predictive coding tool that is part of the product. The tool will present randomly sets of 100 documents which you will be able to grade as being responsive or unresponsive, a document at a time. It also provides for a monitoring of human versus machine review and resolution of discrepancies between human judgment and the machine judgment, and also how to tag the results for inclusion in the organizational structure that you've created for the case. Punching on the word predict. And we come up with a dashboard that will reflect where we are in the predictive coding process. Before we come back to that dashboard, though, I want to take you over to the review screen and show you exactly how we operate the predictive coding module. In using predictive coding, the product will choose at random 100 documents at a time and will present them to you for rating. You rate them over here at the left as either being responsive or non-responsive, or at the top of the screen you can have that too. And so if we wanted to call this one non-responsive, we'd punch on it as non-responsive. It'll automatically move us to the next document. Let's suppose we rate that one non-responsive and we move on to the next document, but perhaps we rate this one as being responsive. The U line in the middle is undecided, okay? And once you've started this process, and we've actually taken it through 21 samples of 100 documents each to get to the point where we are as reflected on the screen here, it will start the software will start to rate documents on its own. and where it is not certain, or where you've had a differing point of view, it's going to show up by way of a check mark, and you'll be able to go in and take a look at that document and resolve that issue. The product rated this document is unresponsive. You might even want to change that to being responsive, and that will resolve the discrepancy. Toward the end of the process, you'll get a discrepancy report, and I just punched on that discrepancy item there. And this will show documents where the product is uncertain as to whether it's made the right choice or not, and you should go in and resolve each one of those discrepancies. The goal of the process is to align the results from the product with the results that you would have had rating it as an expert. You can see that we have a chart here that will show a comparison of the differences between the computer rating and the expert rating. You should work to the point where those differences are pretty much resolved. Once that is done, then the computer will have learned enough about the data set to go ahead and assemble documents of like kind through its associative processes. Once you've completed a relatively small sample, say 5% or so of the data set, the machine will likely have learned enough to associate the content of the balance of the data with respect to this issue. And you merely punch the commit button, and the computer will go do its work and assemble a set of records that you can rely on as being relevant to the particular issue. I should also point out that you really want to do this process with respect to each issue that you have determined to exist in the case. So you may be going through this process with respect to maybe 20, 30, 40 different issues, and it's still going to be a lot faster than merely reading the documents, and it's going to get you relevant document sets with respect to each issue. It's important to note also that the user is always in control of the predictive coding process. You control it by rating the documents as responsive or non-responsive, resolving differences, and actually going through the process multiple times to reflect the multiple issues that you have to resolve in your lawsuit or other matter. The predictive coding process is one of rating documents to create subsets or within subsets as produced. And you can also actually alter this process somewhat by the introduction of exemplars that are external to the process so that the machine can learn from them as well. We have monitoring of the human process versus the machine process. Tables will actually show you where you stand there, and we can resolve any discrepancies through our discrepancy resolution process. Once the document set new document set has been created through the predictive coding, we go through the same tagging process that we demonstrated earlier. So by way of review, in this demonstration, we've talked about how you organize the structure of your case by creating lists of issues, persons, and the like, developing a tagging structure to reflect that. Then we've shown you how to explore on data using our concept search and clustering tools, and then how to resolve with final data sets of from large data sets by use of predictive coding. Now that we've come to the close of our product demonstration, we would like to invite you to engage with us, or you can call or drop us an email. We'd be happy to discuss your requirements or anything that was in the demo, and we look forward to hearing from you.